Hey you guys, welcome back to the channel PHYSICSSIRJEE, and we are in the Pathfinder solution series, and the topic of chapter 1, Kinematics, check your understanding, problem number 19. It's a cute little problem when you read through it. There are multiple solutions for this. One of the ways to do it would be to write equations and solve, but we will be looking at a slightly different and graphical and a shorter solution. Okay, so let's go ahead with the formal wording of the question. In case you have not tried this question before, please make sure you pause the video here, try to go through the question on your own, and then come back to the solution and the concept that I am going to explain once you give it a fair try of, let's say, 2 to 3 minutes. Okay, right. So here's the formal wording. Two boys are standing near the ends of a 100-meter long conveyor belt that is running with a constant velocity of 1 meter per second. The boys step on the conveyor belt on its opposite ends and start walking towards each other. After meeting, they immediately run or return towards the ends of the belt, and then they continue the process repeatedly. The boys walk with a constant speed of 3 meters per second relative to the conveyor belt. What distance relative to the ground do the boys walk in the first 300 seconds? Okay, so this is the question. So let's move ahead with the solution of the question. So on the right of the screen, a lot of things are on the screen, just follow my lead. On the right of the screen, I have depicted a crude diagram of what would be happening. So I have said that left end of the conveyor belt as x equal to 0 and right end as x equal to 100 meters, that he said is the length of the conveyor belt. I have depicted that conveyor belt is moving towards right with 1 meter per second. I have not used the units here, it's self-understood. And each boy is supposed to walk on the conveyor belt with a speed of 3 meters per second relative to the belt. So it's obvious the boy who is moving towards right will get aided by this one, and therefore with respect to ground would start walking at 3 plus 1 meter per second, that is 4, and this boy would be slightly slower with respect to ground in this direction at a 3 minus 1 meter per second. Okay, so the idea is this green color velocity and this red color velocity, because they're in opposite directions, I'm trying to depict that on a x versus t graph. Okay, so this is a graph that I've drawn to depict simultaneously the motion of each of these boys. Okay, so let's start with the green colored velocity, right? So I've shown it in green color here, right? He's starting at x equal to 0, and the slope of this graph would be nothing but the velocity. So slope is 4. Just imagine in your mind, if the other boy was not obstructing this guy, then he would have gone with a slope of 4 meter per second to cover 100 meters. So at what time would we do that? 25. So that's how this shape would have been had he been not interrupted by the other boy. Okay, whereas you go ahead and do the same logic with the 3 minus 1, which is the red colored velocity, which is 2 meter per second. So this slope would be slightly less steep and therefore would take 50 seconds to complete the 100-meter journey. But the problem is they bounce off each other at somewhere in the middle, and that easily relative velocity wise would come out to be at 2/3 of 100 meters. So they will meet, obviously this boy is twice the speed as this, so they meet at 2/3 point. So how do I depict that on the graph? So whenever they meet, the red color becomes blue and blue color becomes red is the way I depict that. Okay, so the person who is walking with a greater speed now starts moving. Can you see this slope and this slope are same? So you can visualize the bouncing off as like this. So person who is walking faster meets the other boy, starts walking in the opposite direction. So he would be going like this. Whereas the person who is walking in the reverse direction meets this guy and starts walking backward, then he ends up getting the slope of this. Okay, so now if we continue, they reach the ends at 2 different times. These are right their respective ends. Then again they start, and again the bouncing off will happen, right? So this line obviously will be parallel to this line, and this line is parallel to this line. So it becomes a geometry problem on the graph now. Wherever they meet, they bounce off. The red becomes green and green becomes red. So the boy who started at x equal to 100 will follow this graph. Can you see? Whenever he bounces off. And the boy who started at the left end, that is x equal to 0, will follow this graph. Okay, right? And you could clearly see that they reach their respective ends, that where they started. The first one reach x equal to 0, and the second one reach x equal to 100 simultaneously after 75 seconds. which means this entire process will repeat after every 75 seconds. We realize the motion entirely repeats after 75 seconds. It's a simple geometrical analysis that you can do on the graph paper, okay, which immediately tells you that in 75 seconds, each of these, you could see the lengths of this, right? So this distance traveled you can calculate, this distance traveled you can calculate, this and this. You quickly realize that the distance traveled by this guy and this part would be the same. Distance is not the slope, remember, distance is the subtraction of the x coordinates, okay? So this, by whatever distance he traveled, this would be the same distance, which is 1/3 of 100, right? So when you start, sorry, 2/3 of 100, then this one would be 1/3 of 100 and this would be 1/3 of 100. So in every 75 seconds, each person will travel 100 times of 2/3 twice and 1/3 twice. Okay, so that would be 200 meters. And he has asked in the question that how much distance each person will travel in 300 seconds. So 300 and fortunately is a multiple of 75. So this entire thing should, or this graph should repeat 4 times. So the total amount of distance that each person has to travel would be 4 into 200, which is 800. I firmly believe this question would have appeared in one of the Olympiad exams. This would have been a more fetching solution than writing actually the equations and solving. And this kind of an approach is also useful in other problems in the Pathfinder book, where actually two people start meeting and there is a fly going around back and forth. There are also questions where there is a bus service going from one town to another town and there are people cycling in opposite directions. They meet certain number of, so all these problems can be reattempted, and if you believe this solution would be valid, I have done them, so I'll try to include the solutions of those also later. But I would urge you people to actually take those as practice problems, and it will be more fetching solution than the ones that we get from writing the equations. Okay, so on that note, in case you have liked this particular video, please do check out the rest of the Pathfinder solution series and Olympiad workout series, AITS select series, and result series. All these are the important series that are running in this channel, and all the links of the playlists are in the description below, so it will be worth your time for sure. And if you have liked the video, please do share it, and please do subscribe to my channel, and also request your friends to subscribe to my channel, and try to bring those people who you feel are going to benefit from my channel. Okay, right? And thank you, and see you in the next video.